All right, so molarity, folks. This unit with solutions is super important, super applicable as well to life. Pretty much all of life is based on solutions. Without them, you guys wouldn't be alive. Nobody would be. I wouldn't be. Nobody would be. How many of you guys had something to drink this morning that wasn't water? All right, most people. How many of you guys got to school here by riding in some sort of vehicle that wasn't like manually powered? Solutions. Without that, you wouldn't be here. All right. How many of you guys have ever been in the hospital before and had like an IV in your arm? If those IV bags are even off by even the smallest percentage, folks, all right, they would kill you. All right, and that's not trying to be morbid here or anything like that, but it's something like that. They go through a lot of regulations, folks, to get those bags of whatever solutions that are in there. They have to meet certain criteria. Medicine. How many of you guys have ever taken like a liquid medicine before? All right, pretty much everybody, right? If they're off, even in the slightest degree, again, they may not work, or if they're too highly concentrated, they could kill you. All right, guys, solutions is where chemistry happens. How many of you guys thought when you were taking chemistry it was going to be explosions all the time? Okay? Explosions all the time. There's always some. We haven't done a lot, have we? Not nearly as much as you thought, guys, because chemistry really takes place in solution form. When I was in grad school, I've done this calculation we're about to get into probably thousands of times. Bless you. All right. And pretty much all of my work extensively was done in the solution form, trying to get things to dissolve, to then be able to run on instruments to figure out what their concentrations are. That's what chemistry really is. It's in the solution form where you're mixing things together to then be able to get different products that may be solids or maybe gases as well. But most of it's done in the solution form. So the biggest thing that we're going to look at, guys, is molarity. It's how we measure the strength of a solution. All right, and that's something very critical to know. It's measuring the strength of a solution. So there's different concentrations, units that we can use. Molarity is the most common. And that's capital M equals moles of solute per liters of solution. Notice that this is an extensive property. So we haven't talked about extensive and intensive properties in a long time. All right, but this unit's going to have a lot of review in it. All right. What's an extensive property? What does that mean? Lauren? Yeah, it changes with how much you have, folks. So like mass, size, those are different extensive properties. Molarity is one. Where an intensive property, what's an intensive property? It doesn't change with the amount that you have, right? Something like density, all right, that doesn't change. It's a mass per volume, all right? But molarity, the more moles you have, the more concentrated your solution is going to be. So I keep throwing that term out there, guys, concentrated. What does that mean? You've heard that term before? Concentrated. Anybody ever make juice from concentrate? Like grape juice or orange juice? Never tasted as good as what you get in the store, right? It can. Depends on how you make it. How many of you guys have ever made like Gatorade or Powerade from like powder before? Have you ever done that? Does it ever taste exactly the same?
If you know how to do it right.
If you know how to do it right, it can taste better. Right, you can put all as much. Yeah, right. So, are you one, Ethan, that likes to have more powder in there? Right. How about nowadays, guys? They've got regular Gatorade and they have G2. Anybody ever have G2? Yeah. Does it taste the same? No, right? Why?
It's low calorie.
It's not that it's just low calorie, guys, but there's a reason as to why. What? No, it's not that.
There's less sugar.
It's less concentrated, guys, and here's why. All right, for you athletes out there, all right, you really shouldn't drink Gatorade, regular Gatorade, while you're working out. It's more of a recovery drink for after, because you sweat out all these ions, potassium, sodium, magnesium. All right, just to name a few. You want to replace those afterward, and that's the purpose of Gatorade. While you're working out, you should be drinking water. What G2 is, and what they've done, they have that whole G series, right? The before, the during, and the after. G2 is during, so there are some ions. So what it is, it's diluted. It's not that it's low, it is low calorie because it is diluted, but folks, the purpose behind it is so that it's not as concentrated, so you can drink it while you're working out, so it's more water-based with some ions in there to replace them as you go along. That's the purpose of G2. It's not that it's, you may not like it and stuff. It's not that it's low calorie trying to make a diet version. It serves a purpose because if you have too much salt, you can dehydrate yourself while you're working out, or you can actually cause cramps even though it's, to prevent it. All right? So that's what we're talking about here with concentration. It's all based on moles of solute per liters of solution. So molarity is the unit that we will use. In the back stock room, folks, I have a ton of different chemicals. Some of those are concentrated acids. One of those that we have back there, a few of those, it's multiple bottles of it, is like 18 molar sulfuric acid. Super, super strong, to where if I left it on the floor, it would start to corrode and eat away at the floor over time. If you got it on yourself, it would burn you and it would not feel good and it would ruin your skin or wherever it touches. Okay? So we don't use that in a lab setting because it's way too concentrated. I will take some of that when I need to and dilute it down. We have so much back there, we're never going to run out here at this school. All right? Because it was ordered by mistake. All right? There's a lot of it. I have to go into the fuma, take a lot of precautions when I dilute it because it's so strong, but then it makes more. We're going to see how that process is throughout this unit. All right? Question. What do you notice about this formula? There's two things that you should notice. Moles, you got to have moles. And you got to have liters, folks. All right, there's some of us that, nope, not 22.4, okay? Because that's dealing with a gas. We're not in the gas state anymore. We're in the solution, the aqueous state now. So here we go. Let's dive into a problem, guys. What is the molarity? So it's big M. All right, it's a big M. Make sure you write it properly. It's to not confuse. What's little m? Mass. Nope, not moles. What's moles? N. All right, we did that in our last unit. So we're looking for molarity. All right, we've got a volume that is 250 milliliters. What do we need to do right away? How do we change milliliters to liters? Divide by 10 to the third, which is 1,000. All right, so really, guys, what you're going to do when you see milliliters, move your decimal place 3 places to the left. This is 0.25 liters. And then we have a mass that is 12.7 grams. And here comes the review. You're going to be given pretty much exclusively, guys, in this unit, you're going to be given the names of compounds. You have to write the formulas. So if we don't have prefixes in the formula, what method do we use to write our formula? The crisscross method, guys. So lithium, what's the charge of lithium? So we're having your periodic table out. It's going to be handy. What's that? +1. Bromide is? -1. So my hope is by now, folks, you should be able to look at the charges without having to physically write it. If you need to, do it. Don't be too lazy to write it out. But guys, what's our formula going to be for lithium bromide? LIBR. So we have grams. We have now converted to liters. But our formula says molarity equals N over V, and that's going to be moles over liters. Do I have moles? No. Can I get to moles? Yes. How? Stoichiometry, right? It's just a one-step problem, guys. Really, you're just dividing by the molar mass. So 1 mole of LIBR is a certain number of grams of LIBR. Go ahead and calculate the molar mass of lithium bromide. All right, so when you add lithium and bromine's molar masses together, what do you get for the molar mass of lithium bromide? 86.84. So do the math. 12.7 divided by 86.84. What do we get?
0.15.
So here's the deal, guys. Do not round your numbers early here. You should go out to 3 or 4 non-zero decimal places. Wait to round until the very end. Because if you round early here, your final answer, molarity, could be off significantly. It could be off by, even 1/10 of a molar unit, moles per liter, and that's a huge deal. Okay, like I said before, right? All those solutions that are a certain molar volume they put in your body at the hospital, if they're off by, 1/10, that could have drastic effects on your body. So do not round until the very end. So if we go to 4 decimal places, we get what? 0.0000. No.
0.1462.
1462 moles of lithium bromide. Now I've got moles, I've got liters, so I can plug it in. Big M equals 0.1462 moles over 0.25 liters. What is my molarity going to be? Now you can round, folks, to correct sig figs. We will have 2 sig figs we'll report our answer to here because of the volume that we had. 2 sig figs. What do you get? 0.51? 0.58, excuse me. Moles per liter. Now there's 2 ways you can write it, guys. It can be 0.58 moles per liter, or it can be just 0.58 molar with a capital M. Either unit is acceptable, because what molar means, guys, is it's molar molarity, moles per liters. All right? So, either or is acceptable. I don't care. Make sure you know, though, that if you write capital M, what it stands for. Moles per liter. Take a look at your formula page in your reference packet. Do you have to memorize this formula? No, you do not. It is right there, guys. All right, and it says molarity equals what?
Moles of salt.
Moles of solute over liters of solution, guys. So it tells you the formula. You don't have to memorize it. You've got to know how to apply it. Questions? Mathematically, guys, is this anything new compared to what we've done this year? Not at all. Go ahead and do the you try problem. So these are your variables that you have. All right. We've got to get to moles. So what do? Divide by the molar mass. What is my molar mass for sodium sulfate when you have the correct formula of Na2SO4? .05. Either or. Either 04, 05, I'd take either. Now, when you do the math, how many moles do we get of sodium sulfate? 0.2253. Now, I know it seems like overkill to go out that far, folks, but I'm telling you, if you round too soon, it's going to mess every calculation up after that. All right, so plug it in. Molarity equals 0.2253 moles divided by 0.45 liters. Molarity is going to equal what here in this problem? 0.50 moles per liter, or just big M. All right, not too bad. Now, that's one way, guys. The other type of problem that we could see, all right, is the next example where, okay, it's asking you how would you prepare a solution like that. Okay, so it's going to be a little bit extra you've got to do at the end. So we're trying to make a total volume of 500 mils. What do we need to do with this? 0.500, and all those decimals are important, folks, following sig figs. All right, that decimal was there. You got to keep all those zeros at the end. There's our liters. We're given the molarity this time, 0.32 moles per liter. So it says, how would you make? So what are we really looking for here? In the end, guys, when it says how would you make, that means grams. You're looking for grams in the end, but does our formula give us grams? No, it gives us moles. All right, so we're looking for moles first, and then we'll be able to get to grams. So here we go. Molarity equals N over V. How do I get N by itself? Multiply by V. Those are gone there. So it's really N equals V times capital M. So N is going to equal 0.500 liters times 0.32 moles per liter. Liters are gone. So my N that I get, that's easy math, 0.16 moles. Now we're looking for lithium bromide. So guys, when it says how would you make, you need to figure out how many grams. We already calculated the molar mass, so now we're doing the opposite. Before, the last problem, we divided by the molar mass. Now we're going to multiply by the molar mass to figure out how many grams we need. Because we can't measure moles. There's no instrument that measures moles, but there is an instrument that measures grams in the lab. So we said it was 86.84 grams over moles. Moles are going to cancel out. We're left with grams. Do the math. 13.894, we can round that now, 13.9 grams of lithium bromide. And how you would actually write it, well, you would say you're going to take 13.9 grams of lithium bromide and then put it in a container and fill to the 500 milliliter line. We'll talk more about that tomorrow, guys.